Streaming? Kilobits per second says good. Am I up yet? Line is unstable. Hello, am I back? Hello? My internet went down. So thank you whoever stuck by the stream and waited for me to come back. My cable modem completely went down. I don't even know if I still have the transcoder or not, because I need to reload my dashboard to see that, I guess. Hi, I'm back. Well, I'm not going to let something as silly as losing my internet connection stop me from finishing tonight's work. I'm almost done. I have the Flash programmer built in. It just has to commit to reprogram. So I was in the middle of coding this loop, and all of a sudden I noticed that my OBS had disconnected, and I'm like, ooh. I'd never stopped recording, so when I upload this to YouTube, if I upload it directly, it'll be with everything in it, and but if I upload from Twitch, there'll be a section lost, and this will be in 2 parts. So I don't know. Can anyone tell me if I have the transcoder or not? I don't know why I'm obsessed about that, but I am. Anyway, so I guess we'll just code this like this. Let mute. Let's call this base. Base offset. I need a name, another name. How about sector? Dr. Horrible, how are you doing? So while how about we call this start or from? From. I like the word. No, from is reserved, right? No, it's not reserved. Then I can call this offset. While offset is less than size, and we're going to need a sufficiently large buffer. Sector size, right? Why am I typing it when I can just copy it from here? Howdy, Ramy. I'm back. My internet connection is back. It's just standard. Well, let stage equal. It's going to be from plus offset. As a pointer to slow down, Raimu. Constant pointer to constant U8, and then standard or core mem. What's this? Yeah, I am going to mutate it. Copy, not transmute copy. How do I do a like straight memory copy in Rust? In not standard, is it just core intrinsics copy? It's unsafe, that's fine. Okay, we can do unsafe. Source and then destination, okay. Intrinsics. Intrinsics copy. From stage to flash. We need to actually have a pointer to flash, don't we? No. It's stage to sector. As mute pointer. Sector size. And then offset plus equal sector size. Hey there, worship the sofa. How are you today? Yeah, it is unsafe. We're doing very unsafe things in this. What if I just make the whole thing unsafe? And then we'll just make this guy deal with it. So, sure. Committing to reprogramming is unsafe, but sometimes you gotta do it. Because of this. Is it pub unsafe function? That's it. Okay, and then offset. Can't add to it? Oh. Yeah, that is a U32. Okay. And then after we copy into RAM, then we can program it. In this case, the offset will be offset, and the data is sector. And borrow it. Okay. Am I done? Make sure this is right. Okay, because if this isn't right when it boots up, it'll just crash. Starting at 0, we have an area in RAM, and then while we're not done programming, we get a pointer into Flash where we're actually going to read from. So this from will be given to us as the staging area, right? Let me make sure that it is. Yeah, the staging offset, right? Which is 1 megabyte into Flash. Oh, I have to add the Flash base to that. Okay, that's a bug. I have to add... I had Flash base in here somewhere, right? Flash base. I need to add Flash base to from. Flash base plus from plus offset. So we set that up as a pointer, and then we use the intrinsic copy to copy that's source to destination. So source is the stage, destination is RAM, our RAM buffer. And then from the RAM buffer, we program the sector in Flash, go to the next, go one sector over, and then as long as we're not past the end, we continue going from that offset. I think this should work, because when we get to the end, we just reboot, and then... Okay, let's try it. If this works, this will be the last time I have to run this Flash command. Ba-da. Ba-da. Okay, let's see if it works. It didn't work. Well, okay. Is it totally hosed? Ba-da. No, it's not totally hosed. Interesting. So this is going to be hard to debug then, right? It's either running my new program or it's running the old one. How about... How do I know if it's running the new one or the old one? I guess I can build it, flash it, then change it, build it again, and then use this one to flash it. Yeah, I'm back, Tinspin. I lost my internet connection. I was down for maybe 5 minutes, and then it came back up. I had to restart. I had to stop the OBS stream and restart it, but I never stopped recording. Saw the Pico W come out today. That headers are on it are sold out. You can solder your own headers on. It's not fiber, it's cable modem. It's the copper. Can you alternate the color or blink rate of the LED? Oh, that's a good idea. Yeah, I guess I can try that. Although I'm hoping to see that there's a bug here somewhere. This is the only difference, right? Is the commit to reprogram. We're putting it in RAM. It's not inlined. It doesn't call anything. Oh, wait. It calls watchdog.start. Oh, I bet it worked, but it crashed when it tried to call watchdog start. You know why? Because that's in Flash. Yeah, okay. Yeah, we can't call watchdog start. We have to program the watchdog ourselves. That's some counter? Because it's no longer a counter because I'm using that same address to stage our Flash. In fact, I should remove the Flash experiment now that I remember it. Well, if I remove it from here... Yeah, we're done with the Flash experiment, right? Can delete it. So it'll be called from keyboard somewhere. Here. Done with that. Okay, so I need a substitute for the watchdog. And one thing we could do is we could, if we knew how long it takes to reprogram the Flash, we could start the watchdog before we start reprogramming. But I would have to know how long it takes. I think it's safer to just have the code to restart to kick the watchdog ourselves. Shoot, where would it be? Thing is, it's through a trait, so I need to actually find the actual implementation. Actually, would this work? Can I click on this and say final implementations? Oh, there we go. Due to a logic error, the watchdog decrements by 2 and the low value must be compensated. Bury it into integer times 2. Times 2. And it's milliseconds, right? But presumably it's milliseconds. Is that really milliseconds? I don't know what it's converting it into. Oh, it's into self-time. Probably because this load counter takes U. Okay, it's U32, but that's probably not milliseconds, but microseconds, I'm guessing. Okay, enable, what does that do? Watchdog control write and enable bit. That's a trait we're looking at again. No, it's an implementation. Can I just... I'm just going to go for it. So, this is what I'm going to do. Instead of... Instead of trying to program the watchdog directly right when we're going to reboot, we're going to set the watchdog to go before we start programming, and we just have to set this to an appropriate number of... How about we do seconds? And let's give it like 5 seconds. It really wants microseconds? Okay, fine. Then how about 5 million microseconds? So this will cause it to absolutely reset after 5 seconds, even if we crash, right? It's just what color it comes up as afterwards is what matters. Yeah, we don't need this anymore. We don't need interrupt and we don't need info. Actually, we do need interrupt. Hold on. Don't we want to lock interrupts when we're doing this stuff? I forgot all about that. Yeah, I do. Let me undo for a bit. I should be totally locking interrupts, now that I think about it. Okay. Redo. This should totally lock interrupts. I don't know. Okay. I don't know if I give it a closure, will that closure be in RAM? I don't know. I'll worry about that later. Let's just get this working. I'm not actually using interrupts, so it shouldn't be a big deal. We'll give it 5 seconds to reprogram. That's certainly enough time. And then how would I know when it's actually done though? Oh, I have an idea. I could, if I know how long it takes to program a sector, I can just kick the watchdog. Why don't I just do it that way? So, we were seeing that right here. Yeah, okay. So we know how long it takes roughly to program a sector, right? No more than whatever this is. So we can say 100 milliseconds. Yeah, why don't we do that? So 100 milliseconds. Or 100,000 microseconds, right? And we'll just kick the watchdog or feed the watchdog every sector, and then when it gets to the end, it will, after 100 microseconds, it'll just reboot. That should work, right? Oh, except for this calls into Flash. Okay, we can't do that. But knowing that it's 100,000 microseconds, I could multiply by... I know what I'll do. We'll estimate the maximum time it should take to program by 100,000 times the size divided by the sector size. That's what I'll do. So that's how long maximum amount of time it should take for us to program it. Then we go and we do our reprogramming, make sure we don't call anything in Flash. That actually might be dangerous to do. This actually might, it says inline. Can we trust that it really is inline? I'm going to trust that it really is inline and that it's not calling something from Flash. And then program sector is also in Flash, so that should be fine. And then loop, and then we should be done. Okay, let's try this out. Last time we're going to Flash, right? Now I'm going to change the color of the keyword here. I should have made it a constant. There it is. Let's go to green. 0, 255, 0. So here I'm going to build only and not run the programmer. Okay, and then going over to here, I'm going to run my programmer. Goes nothing. It's still purple. But it did reboot. What does that mean? Reset. It's still running the old program then. Bummer. Because if I were to flash this in to verify, right, it should come up as green now. Yeah. Okay. So yeah, I gotta... what? So maybe we're not waiting long enough? Either that or this is crashing. Okay, that's what I think I should be able to wait for. Let's have it wait for like a good 5 seconds. Like hard-coded. Right? Build. And let me go change the color here. What color we want to try? What's red plus green? That's like, I don't know, what does red and green make? I can't think right now. Is that yellow? So it should look yellowish? Yeah. So build the... yeah, yellow. Build, if I can type. Here we go. 1003, 1004, 1005. Okay, so I guess I'm not copying it to the right place. Or the flash programming is working. Aha! It's gonna be like that, huh? Thank you, AutoMod. Turtle Pies, how are you doing? Okay, so the watchdog is working, and so we're either crashing or we're not, or we're programming to the wrong location. So how can we tell which one it is? Can't really tell, right? I'm not sure what to do. Okay, I can make sure this vector is in, no. I was gonna say make sure it's on the heap by getting a vec out of it, but then I'm not I want to avoid at all costs calling something from Flash. So maybe I do want to get rid of this copy and just do it manually. We can do that. Stage and then Flash is without the from in it, right? And that's a mutable reference. Then this would be for I in, or for, yeah, I in 0 to sector size. Flash index I equals stage I. Actually, I don't even need don't know if I needed that dereference. Oh, I can't do that? Okay, then it's just going to be flash equals stage, and we'll advance the pointers. Comment this out. flash dot how about flash equals flash dot offset 1? And then I don't need this variable. So these are inlined always, that's good. Oh, wait a minute, what am I doing? I can't copy directly into Flash. It's too late for me. This has to say, yeah, I need the I here. This should say sector I. Get rid of this one. I didn't know you could iterate that, but okay. I don't know why it's telling me I can iterate. Is it because of that can't be the reason? Nope, that's not it. Why am I getting a warning here? The loop variable I is only used to index sector, correct? Consider an iterator. How about no? How about I ignore that? Let me just try this. So now it should be yellow. Yeah, it's yellowish. So we'll go back to green. Build it. And then program it here. Two, three, four, five. No, it's still yellow. It's not actually doing it. Grr. I'm at a loss to explain it. We know that works, right? Program sector. Yeah, none of this is in... Oh. Is this in Flash? This can't be, right? I'm kind of tempted to look at the disassembly of this. So what was that again? Cargo nightly read obj. Disassembly. Can't for the life of me spell right now. Is it not read obj? This is why I should keep notes. I'm trying to find in my notes where I wrote this down. elf headers to hex UF2. Where's the disassembly one? Okay, forget it. I have another way of doing this. Do I still have that project open? I don't. So I'll open it again. And here I had a README with a cheat sheet in it. It's object dump, that's what it is. Not read object. OBJ dump. And that's disassemble. Okay, and then look for commit, right? Okay, so it's gonna jump. Oh, it's right there. It's putting it right here. So it does jump into Flash to set up the watchdog, right? Mem clear 4. What is that? 1B8. Beep beep. Beep beep. Oh, it is jumping into Flash for mem clear for some reason. TLDR, I'm working on a keyboard as the overall project, and I'm trying today to get the keyboard controller here to be able to reprogram itself. That is a thing. Is my bot... Oh, my bot probably lost its connection. Hold on, let me start it up again. Yeah, I think when I lost my internet connection, the bot lost its connection and didn't recover. Yeah. Okay. Beep beep. Beep beep. Oh, this mem clear must be setting up the RAM area. Yeah, it's setting up a 4 kilobyte thing. It's weird how it's calculating these things. Anyway, whoa, what is this? Huh. Oh, that's the copying into RAM, right? It's just unrolled. The loop has been unrolled. Okay, and all right, and then at the end, it jumps to FC to program the sector. And here's the infinite loop here, branch to itself. What's at 4E? Yeah, okay, so this doesn't jump back into Flash while it's doing its thing. Program sector. Let's make sure that it doesn't go into Flash either. Made the firmware in C? You could get stuck with the PCB stuff maybe? You mean on the RP2040? I'll take down the link. Say copy link. Put it... My personal notebook is where I'll put it. I'll check it out, thanks. Yeah, I am making my own PCB. If I don't give up on this. Oh, right, it's looking up flash locations there. Yeah, okay. So I think we're safe. The thunk to watchdog enable, yeah. These thunks, you need these thunks whenever you go make a very large jump, because in the thumb instruction set, you're limited to how far you can branch. So when you jump between flash and RAM, you'll have these thunks. Beep, beep, beep. Whoa, sorry about that. So it is jumping back to flash temporarily to clear the RAM initially. I don't care about that. Okay, so it doesn't look like it's jumping back into flash when it shouldn't. So is there something else? I could put the intrinsic back in and make sure that it looks okay. That's what I can do. Save. Getting slow in my fatigue here. Commit. Next. Okay, here we go. There's where it clears the memory. Okay, there's a mem move thunk. Okay, so we can't do that because it's definitely calling into flash to call mem move. Beep, beep, beep. Yeah, right here. We can't do the intrinsic because it jumps back into flash. Definitely can't do that. So we have to do it this way. So maybe there's something wrong with this. Flash base is 1 and all zeros plus that plus that. I mean, that should be fine. See where this is called from keyboard. Right, 1 megabyte in. Okay, I know one way to verify it is programming the correct location. I can just program zeros in and not do this copy at all, right? If I don't do this copy at all, it's going to completely wipe out and it won't boot. And I'll have to use the ROM bootloader to recover. So I can do that as a way to verify it. That's what I can do. It's just a process of elimination of where I'm getting things wrong, right? Ba-da. Ba-da. I'm back to green. Okay, so then I'm not even going to bother changing the color of the LED. Dang it. Too many windows open. I just want to reprogram it, and it should wipe it. It should actually not program, it should wipe it out. Ba-da. And it didn't. Okay, so the program flash is bad somehow. That's what it is. Because we shouldn't be able to boot now, and we are booting, so that's definitely it. So where are we, it's either we're not programming to flash at all, or we're programming to the wrong place. Let me confirm that this offset really is from 0. So pulling up the datasheet again. And I'm going to go to that boot ROM. Scroll down a bit. Okay. Offset from start of flash is the address. Offset from start of flash, okay. So yeah, program multiple 256, address must be aligned to 256 sector. One thing is we're constantly exiting XIP and then re-enabling it. Would that matter? It shouldn't matter, right? Yeah, I don't know. I don't know. It's almost like this is all skipped or something. I don't know. What to try next? It makes me doubt that program sector is actually doing anything, but we verified it was programming before, so what's different now? Let me put a dump of the stage back in there, because we're actually able to program, so maybe after programming the sector, we'll read back and print out the first 16 bytes of it. Yeah, that sounds like a plan. So, actually I can do it right here. There's nothing that says I can't do this, right? The data and the base. So that would be offset flat. It would be flash base plus offset as pointer to constant U8 and what was it? From raw parts, I think is what I was using, right? Yeah, this thing. This thing here. And just 16 bytes is fine, right? And this is the offset. Its operation is unsafe. Indeed it is. Okay, let's see what that shows us. Build. Tired, can't type. Ba-da. 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 There it goes. Here we go. All right, so I need to compare that against the bin that I have. So that would be under target, thumb v6, and release this bin here. Open it in hex editor. It sure looks like it matches. Okay, and then go 1000 in, one sector in, and what do we see? FEDEOE. Yeah, that's what I see. I mean, it looks to me like it's working. Let me go to D0. It's actually, it's at least able to write it to the staging area. 3066. Yeah. It's writing that. Then why is it that we can't copy it back? I'm missing something, I think. Those offsets were... Wait. Okay, yeah. That's the offset of the staging area. Okay. Then here... You have a circular green screen taped to the back of the chair. It's blue. Oh, you're seeing a little bit of an edge there? It's because I turned my chair. Yeah, it's a web around. We make a petition to make your Papa the standard USB sound? Go for it. Yeah, I mean, I normally wouldn't mind, but Mrs. Roymo doesn't like people seeing the house behind me. Don't know. Don't know what to do here. Missing something fundamental here, I think. But this should write all zeros, right? Why isn't it? I don't know. The only thing I can think of is it's crashing before it actually gets here. Or it's crashing when it tries to call into there. But it shouldn't. I can't think of why it would. We're calling it done here, right? What can I test now? Not calling the watchdog maybe? And just manually resetting it? No, we know, okay, the watchdog works. Can I do anything that has a side effect here? Not once I start programming, right? Actually, what happens if I call back into Flash at this point? No, okay, we're not servicing the USB anymore, right? Because it gets stuck in here. Nope, I'm stumped. Totally stumped. Disassemble it again. Okay. It should be greater than or equal to the program size, because the last sector is hardly ever going to like round up to the program size. I mean, the program size is never going to round up to an even sector, so it'll be beyond it. That's fine. But the problem I have now is that what it should be doing is taking this buffer full of zeros and programming that directly into Flash starting at offset 0, so it should blow away the bootloader, and so it should not boot up. But yet it boots up, so that tells me that it's not successfully programming it or erasing it at all, and I don't know why. It is a mystery. Okay, it's obviously setting up the watchdog and enabling it there. And then it's clearing a bunch of memory. LSLS, I don't know what that is. Should I be looking this stuff up? It puts 1 into register 1, and then moves that 1 into register 6. And then LSLS. I should maybe just look that up. I have nothing better to do. Thumb LSLS instruction. Logical shift left. How about this? This link is probably better. Provides the value of a register multiplied by a power of 2. What about LSLS though? LSLS. Okay, what does it do? Is it just saying that that's the thumb form of it? So it's left shifting by 12. Okay, right. 12. 2 to the 12 is that's 4,000, right? 96. Calculator again. 4096. Yeah, that's 4,096. So it loads the value of 4,096. So it's clearing from the stack 4,096 bytes, right? Mem clear. When it comes back, I don't know why it's comparing R4 with 0. branch to here. Why? Wait, what? Oh, is that the while loop? That must be that, right? For E. Oh, yeah, that would just jump straight out. It's not doing that, is it? What? Why this? Why this compare and branch equal? Okay, R4 is size, right? I guess it's saying if the size is 0, it can completely skip the while loop. Otherwise, okay, I see. It's sort of an optimization. If size is 0, then it knows it doesn't even need to compare offset with it. Otherwise, it will call flash sector or flash program sector with whatever is in R5 and the pointer to where we have that bunch of zeros, right? And then add R6 to R5, and then if R5 is now, I guess BLO is branch of lower then go back to here and then program another sector. So it keeps going and adding whatever's in R6, which I guess is sector size. And at the very end, it just loops forever, and that's where we get stuck until the watchdog reboots us. Because you're checking for equal? No, I'm checking for less than right here. Well, it's less than, but I'm just thinking that we started at 0, and so this is some kind of optimization where it will completely bypass the loop if size is 0. If size is not 0, it knows it needs to run this at least once, and then it doesn't bother to actually compare it until after it's done an add down here. So put the condition like after the add here. Whoops. This add here is this add here, and this compare and branch if lower is there. But for the initial condition, that's this right here. Pretty sure that's what it is. So then,
beep, beep.
What is R4 loaded with? Whatever's in R1 at the beginning. Okay, so that's our argument, right? Our size argument, yeah. Okay. That didn't teach me anything. Read last few messages, please. He said, after the last sector stays, the offset is the program size. And I said, no, it'll be past the size, because this is not an multiple sector size, right? It says, then your equals check is failing. Which equals check? I don't have an equal. I have a less than check here. This is an assignment. This is assignment. This is a plus assignment right there. So I don't know what you mean by checking for equal and not greater than or equal. Do you mean inside? It's not, program sector doesn't have any comparisons at all. Do you mean like when I'm staging it? Because I verified that it's staging correctly. Like here I'm dumping it back out of Flash and it's reading back correctly. It's just, so I can program at those offsets, but I can't program at offset 0 for some reason. Why would it give me a problem programming at 0 though? I can't think of why. Where I'm calling reprogram. Oh. Here? Flash staging offset is, that's the from, which we're not using. The size. I know we're getting into here because we reboot. The only way we're rebooting is if we get in here and we set the watchdog and we don't feed it. So I mean, okay, we could verify we're actually getting in there. Okay, that's a good thing to test. How would we know we're getting in here? We can just reboot. So we can just loop. We can do nothing but that. And I'll set it to like just 1 second. So guaranteed now it will reboot after a second. Right? So build, and we're gonna flash it. Ba-da. Ba-da. Okay, here we go. Ba-da. So it rebooted. Hey there, Romania hate. It's hard to do anything else observable within that function because I have to interact with USB or the NeoPixel to do anything. Should I just have it do a little bit more here? So now we're absolutely reprogramming sector 0 and then going to sleep. So that should blow away the first 4 kilobytes of my program, and it should not reboot after that, right? We're looking for observable side effects. Here we go. Nope, see, it booted. It shouldn't be able to boot. Line 188 has an equal comparison. Yeah. It'll never be greater than or equal to the way I have this set up up here. The current sector size is either a full sector, or if we're the last one, it'll be whatever's left in the size minus the offset. So when we add the size to the offset, it will be equal to size if we're on the last sector. That's just the way math works. So we're programming into the staging area, right? And I had it before. I had it verifying that it was actually working. It was actually getting into the staging area. So after we've saved the last bit into the staging area, and now we go commit to reprogram. I know we're getting into here. I just don't know why program sector isn't working like it works when I call it from here. So, yeah. Yeah, no problem. It was a good thing to check. Hey there, leave me speechless. I am currently stuck trying to figure out why this function over here doesn't do anything. Well, it does. The only thing it does is it does set the watchdog, because if I change it to like 5 seconds, then and I have to count to 5 before it restarts. So that and this empty loop, I think, are working, but what's not working is anything in between. I don't know why. So this is supposed to blow away the first sector of flash. And it's not. Offset 0, it should do a 0 there. Erase 0 with 4096 bytes. Zeros. I'm pretty sure I don't need to set anything there. Then program 0 with a pointer to basically all zeros. It should put all zeros into flash. Flash base, right? What is that? Correct. And then what does the datasheet say? Again, I keep coming back to this, hoping I'm see something different, but it says offset from start of flash. So if I erase 0, 4096, it should erase it, right? Yeah, it's Rust. You don't have any clue about the language? I mean, if you know C, some of it will make sense. This is an array. Looks different from C, this part. That's how you declare an array of a specific size. That's a constant right there. 4096. Loop, that's an infinite loop. I have to tell it to allow an infinite loop. If I don't do that, it should give me a warning here saying, this is going to loop forever. Empty loop wastes CPU cycles. Of course it wastes CPU cycles. We just want to wait for the watchdog at that point. Saw the mini breadboard and thought, wow, I must watch this. Yeah, I mean, for what I have so far, I have a keyboard with 2 keys. See, if I press that key, it's Q. Press that other one, it's W. I just need to add more, right? Watchdog is familiar. What the watchdog does is starts a countdown, and if you don't reset the countdown to a number above 0, and if it counts down to 0, it just resets the processor. So that's what we want. We want it to boot back up as if we reset it after we reprogram the flash. But I can't even just erase the flash with zeros right now. It's not doing it. Unless I did something dumb, like I left in the watchdog loop here, but no, I don't see that. I don't know. This is in RAM. I already verified that. What else can I do here? I could read it back and make sure it's all zeros. But how would I know? How would I make an observable effect? I could assume that it doesn't work. Here's what I can do. I can assume it doesn't work, and then just not set the watchdog, not loop forever, and just return, right? So return normally, and then we get back out here, and we'll just go back to the normal state. I'll actually log something, and I'll say, hey, you shouldn't be able to see this normal. And then we'll say this, it should be impossible to see this. This should be impossible. And then I guess we can also we can dump some memory too. Why not? I gotta do that trick again of from raw, this thing. From flash base. And let's just see, I don't know, 64 bytes enough? Should see all zeros, right? Unsafe. Might as well make that public. So I can import it here. This can be U32. Oh, right. As constant U8 pointer. All right. Don't know how useful this is to do, but I guess we can see, like, what is there at address 0, right? Here we go. Okay, so it never got back in. So if I reset, does that mean it won't boot? No, it boots. All right, I'm really confused. This should be impossible because this should blow away the first sector of flash. But if it didn't, it should dump that out, right? How about we print something like... Actually, I can just write this, program complete, because it should be. Let's dump this out at the beginning, too. Where's the beginning? The beginning is over here in new. Where's a good place? Right here? Sure. Okay, there's our dump from first sector flash, right? Where we tried to blow it away and it didn't get blown away. So here we're trying again. Okay, and then I reset it. And there's that connection delay that we sometimes see. Yeah, I know, it feels bad, man. Or is that a Monka S? It's a Monka S. Okay, there it goes. Yeah, see, it's not erased. It's still there. We didn't reprogram it, so we failed to blow it away. Why? Actually, hold on, didn't I change it? It shouldn't even beep. It shouldn't crash at all, right? Because all we did was... Oh no, we did do that. What if I don't try to program the sector at all? Then it should get back out, right? This should do nothing. Sanity check, right? Doing nothing should be observable as nothing happens. Yeah. So it didn't really complete programming, but it didn't crash either. What does that tell me? That tells me that the program flash is... There's something wrong with it when we write over the beginning of flash. Okay, so that gives me some lead, I think. Oh, I have an idea. What if we erase the flash and program exactly what was there before? That should also allow us to continue running, right? Yeah, let me do that. I keep closing the wrong window here. Back here, right? So we'll program a sector. I will copy from somewhere. I will have a stage, but the stage will be just the flash space. Actually, let me copy that line. Just flash space. We're gonna read from flash and then write back to the same memory location. So we're reading from the first sector of flash into RAM, and then programming that RAM back into flash. So that should have a net zero effect. Let's see this. If it crashes, though, that tells me something. Looking at int32, but I can only find this int64 stuff. Turns out it actually is int32. It's just two int32s, one little followed by the same one in big endian. Or are you looking at your Digimon stuff? Okay, that tells me something. That tells me that our flash programmer is broken. That it's not corrupting flash, it's just crashing. Okay. Beep, 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 blah, blah, blah. So maybe there's something in the prefix of program sector that I need to worry about. Let me look at the disassembly. So we're looking at for program sector. Okay, it's at 2D. Or 2C. Yeah, there it is. Pushes a bunch of things into the stack. Doing a bunch of things, looking up, at least it's looking up those function pointers, right? Branching into the boot ROM should be fine. Yeah, I mean, it should be fine to call that function. Wait, why is it doing a mem copy? Did it optimize that into a mem copy? That's a problem. Right? Yeah, hold on. Why is it calling mem copy? We can't have it call mem copy. How do I prevent it from calling mem copy? I mean, I guess it's okay because it's still in, yeah, that should be safe to still call, right? It should still work, right? C4. What does C4 go to? Beep, 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 beep. Yeah, back into Flash. It's a thunk back into Flash. Hold on. Where is my 4 kilobytes of stack? Is that the problem? Plain assignment turning into memcopy. Yeah, it looks like it. But how do I suppress that? I don't want it to actually do that later. I need to prevent it from jumping into there. There, Panapati. Wait, why is it loading all Fs into there, into R6? Oh, I see. It's adding this in order to subtract 1,000 hex, right? Because it's counting on it wrapping around. That's clever. It's adding that to the stack pointer. So in other words, it's doing a subtraction by doing an add of a negative. Okay. Yeah, this is 1 shift left to 28. Which is, give us the address of flash. So it's copying flash into RAM and then trying to program it back to flash, and it's crashing somewhere. You know, I have a wacky theory. What if we're overflowing the stack? Like, does this even do the subtraction if we don't use it? Let's see. It might be optimizing it away. Could it be something as stupid as that? Like, we're just blowing the stack? The stack is hitting something? It shouldn't matter, though. Okay, well, what if it does? Okay, let's see. What happens if I comment this stuff out again? We don't actually... If we have this array and we don't actually do anything with it, does it actually compile? Does it actually assemble into anything? Commit. Why is this behaving like that? Sometimes the shell just doesn't act right. Okay, okay. Oh. It just returns. Wow, okay. Yeah, it's like, nope, don't need to do anything, just return. Okay, that might be it then. It might be that we can't have a 4 kilobyte thing on the stack like that. Alright, that's the theory. So, can't have 4K on the stack. Blowing the stack somehow. So then, let's put it on the heap. So this would be, vec. Let's just turn it into a vector, right? And to turn it back into an array, I have to use that trick, right, where we do as slice. And then try into. And then unwrap. Yeah. Okay, I'm curious to see what the disassembly of that is. Here we go. So it does an allocation zeroed, and when it comes back, we have it in, I guess, one of the registers. Okay, instead of doing a memcopy, now it's doing all those loads and stores, which is good. And then it goes in programs. Oh, and it deallocated it. We don't want it to deallocate. I mean, it's fine, right? Because after it's programmed, our flash should be back. Okay, let's just see if this actually does anything. Like, as in, does it crash or not?
Ba-da. Ba-da.
Let's see. It crashed.
Ba-da.
But when it comes back up, it's fine. Okay, so, let's comment out the, copying. So it allocates from the heap 4 kilobytes. And then, just tries to program 0 with that. That should... Yeah, okay, let's see what this does.
Ba-da. Ba-da.
Ba-da. Reset.
Ba-da.
No, it's still... There's still something there. Why does this say 1... Oh, I put the wrong number in there in the dump. Yeah. But that is the beginning of Flash. Verify that. Right there. Matches that. Yep. Okay. How about we just allocate memory and then free it? Would that get optimized away? Yep. It doesn't do anything. I suppose I could just put this in. Let's see if it does anything now. Nope. It's like no observable... No, it doesn't actually do anything, so you don't need to do this. How do I tell it not to optimize anything out of here? Does it work in debug mode? I don't know. What does it do in debug mode? Does it even run? Yeah, it does stuff. .37c. Okay, it's going back to Flash even to iterate. So that's not going to really work for us, right? Yeah, it's jumping back into Flash just to iterate. To do this part. So that's not going to work. Anyway, it almost seems like it should be something I hand code in assembly, right? Debug assembly won't be readable? Sure, well, it's readable. It's just not going to be optimized. I mean, to write assembly to prevent the compiler from doing things. Exactly, that's what I was just thinking. It just baffles me that at least this does something, but it should do something, and it doesn't. It seems to crash.
Beep beep.
Beep beep. Oh. Release, please. Okay. Yeah, see, it allocates the memory. It actually unrolled a big, you know, copy from flash into memory. Jumped to the program sector, deallocated the memory, checked for an allocation error, I guess, and returns at some point down here. Oh, this is program sector, yeah. Where's the early return then? Oh, this right here, I guess, pop PC. Yeah. Yeah, it's unrolled. See, it did a 32 loads and stores and then added 32 to R0. And then added, yeah, it unrolled the copy. Weird that sometimes it unrolls it and sometimes it insists on calling memcopy. Oh, I have another idea. Just to test if the memory allocation works, instead of calling program sector, we're going to say do nothing with... Actually, let's make the arguments exactly the same. And we'll have another function in RAM called do nothing that cannot be inlined, but it does nothing. Right? What does that do? It knows that nothing is happening, so it just exits immediately. It's like, you didn't actually do anything. Oh, there was a trick to get it to not optimize something away, right? It was to do unsafe asm empty string, right? Oh, imported the wrong thing. Yeah, I use that trick in bare metal programming. Commit.
Beep beep.
Yep. Okay, there we go. Oh, but it didn't do the memory allocation either. It just jumps into do nothing, which returns again. I guess because even though I'm doing all this stuff, I never use them. Okay, what if I this is getting crazy. How do I force it not to optimize away all of that code? I have to do something with it, right? I don't know. I don't care about the offset, but the sector I care about. Thank you, A squared. I didn't know how the syntax for that. Literally have a comment that mentions them? Really? Okay. Yeah, in out reg Do I have to say this mute offset? On integers, floats, SIMD, vectors, pointers. Eight. Can I assign this to an expression? Oh, as pointer. What did I type in here wrong? Oh, you're saying start out as a borrow, but then do as mute and then leave the type off. No, it still doesn't like that. Just in reg then? Without this borrow thing? Oh, it took that. Okay. It didn't like it as a whole though. Huh. Okay, we got it to accept it. Let's try it out. This is such a hack. Oh, it did the allocation. All right. And it's doing the copy. And it's calling do nothing. And do nothing pretends to do something and then it returns. Okay. This looks good. And then it calls deallocate. Okay, let's try this. I'm gonna be up all night trying to get this to work. Okay, it did nothing and it didn't crash, so the memory allocation is okay. Input these pointers into SN that you can't optimize away, yeah. Okay, so that verifies, that tells me that it can allocate the memory. And it didn't crash, so there's something wrong with my program sector function, right? There's something wrong with this. So all I do is comment one out and comment one back in. And this will not work.
Ba-da. Ba-da.
And yeah, it crashes.
Ba-da.
It obviously crashed before it erased us, right? Because if I program in zeros, it never actually got erased. So what does that tell me? It's funny that I can call program sector from here just fine. Where is it? It has no problem calling it here. Okay, what if I add this staging offset? Right? Then it should... Yeah. I'll just put it here because I'm lazy. What if I use this instead of offset? Then it shouldn't matter that I programmed that sector a second time.
Ba-da. Ba-da. Ba-da.
Butter? Okay, so then that didn't crash. So there's a difference between programming the first sector and then programming the sector at 1 megabyte. So, okay, then hold on. What if I just go to the second sector, not the first sector, but the second sector, and try to blow it away. And then when we're done, we'll read back that second sector. I'm going to hand code this. Yeah, this is the wrong thing, by the way. I should put that number. That number should be here anyway. And let's put it at the beginning of the program too. Oh, this has to add that. Shoot. I forgot about that. Plus that. Yeah. We have to do that. Okay.
Ba-da. Ba-da. Ba-da.
So that crashes too.
Ba-da.
Oh. And it doesn't boot anymore. It didn't boot anymore. Okay. So there's something special about the first sector of Flash then, right? So to recover this, I gotta get in a bootloader mode.
Ba-da.
All right. It did something different. The processor? It's the RP 2040. It's a ARM Cortex-M, Thumb V6M architecture. Okay, so what if I read from that location back into there? Yeah, what if I do that?
Ba-da. Ba-da.
Wait, what? I think I hosed it.
Ba-da.
No, I didn't. Let me reprogram it one more time.
Ba-da. ba-da,
Okay. I think my monitor program was doing something funny in the background. Okay, it doesn't crash if okay, so that means I probably am programming the second sector. There's something special about the first sector. Is it protected in some way, maybe? Because that would make sense. Like, what if they put some kind of special safeguard in on the first sector? Like, that protects the first sector from being erased. Sector. Why is it matching set? I said sector. Service? Why is it matching these things? What are you doing to me? Search and... There we go. What's this? What is this here? Reboot? Oh, these are Pico boot. This is from the boot ROM. Yeah, I'm doing cache flushing. I'll show you. That's part of that program sector. It does this flash flush cache, which is the FC function. Flush cache. Oh, wait, what is this 16D8 thing? I'm not doing that. Is that the problem? Could that be it? Let me try that. Because they say, I didn't notice that before. There's a 1 left shift 16 and a D8 there, and they don't explain what that is other than that it is block size and block command. Why is it 16D8? I don't understand, but maybe that is part of it. So first I'm going to verify that if staging offset is 0, this breaks.
ba-da, ba-da.
Broke, right? It crashed.
Ba-da.
But when I reboot, okay, it's dumping in the wrong spot, but that's okay. So now let me add those mysterious numbers in here instead of the 00. They said 1 shift left 16 and then 0xD8, I think, right? Mystery numbers that aren't explained other than that something called a block size and a block command. I mean, what if this just works? I'll be like, huh?
Ba-da. Ba-da, ba-da.
Okay. It worked. Holy crap. Okay. That was it. Let's put the code back in there. I spent, what, 3 hours banging my head against the wall only to find out that there's some mysterious parameters here that have to be hard-coded to something? They'll say D8 is block erase. Yeah, but it says it's optional. That's why I didn't give it much mind. It says, optionally, pass a block erase command, e.g. blah, blah, blah. This will use a larger block erase puzzle for a much higher erase speed, which I don't care about. But what, it doesn't say anywhere that you must do that for the first sector. Okay, so put the watchdog, let's be conservative, 5 seconds. Put this back in there, put this back in there. Comment this out. This is already, we don't need to double comment this out. This can just stay one commented out. This goes back in. Okay, is this right? So starting at 0, get some memory. We probably don't even need to dynamically allocate this anymore. Oh, this should go back to never returning. We're reading from flashbase plus the from address plus the offset into RAM. And then program, okay, this needs to be, I don't know what this was before. I guess this would be offset, right? Because offset is where we're programming into. Yeah, okay, and then advance the sector and then keep going unless we go beyond the size. Okay, I don't trust it. I want to look at the disassembly. And I think you'll understand me not trusting it. Okay, this thing again. Commit. Okay. There's the watchdog setup. There's the memory allocation. Here's the unrolled copy. That's good. It's not jumping back to Flash to do that. There's the program sector call, and there's the branch back. Should go back to 52 before the... Yeah, then it does another copy. Okay. And at the end, we branch to F... Yeah, infinite loop. Okay. Wait, what? Oh, I have some warnings. We don't need to do nothing anymore. What's this warning about again? Can I just suppress that? Up here, maybe. Allow needless range loops, please. Don't need that for now. Yeah, it was back in keyboard, right? That this should never happen. Okay. One more flash, right?
Ba-da. Ba-da.
Should I be super optimistic and just change the program now to make the color different? So yeah, why not? Then I can go to bed when this actually works, and I'll say my Flash programmer is done. Except for maybe needing to be cleaned up again. What color do we want? How about blue? A nice blue. You have faith. I don't. Is that okay? I don't have faith. Okay, we built it here, and now I'm going to use this to program it. 3, 4, 5.
Ba-da.
Yeah! Yes! Yes! It's blue! You guys can't even see the color. Look at that beautiful blue. Look at that blue color. I programmed that. My own code. No, I didn't need to use no built-in bootloader. So, okay, so the conclusion is that these two arguments are magical. They're not explained at all in the data sheet other than to say that they are block size and block command, and that you can pass a command, e.g. D8 hex block arrays. I guess they assume that you're familiar with how flashing works. And they gave me the magic numbers there. I don't have no idea why the block size is 1 shift left 16, unless that's in bits. Because the whole sector size is 1 shift left 12 bytes. So 1 shift left 16 for a block, that must be bits, right? It was yellow. It was green before, and then I turned it to blue. It wasn't blue, it was green before. I know, because the camera's so far away. Here, it's blue. How do I prove it? I'll make it red. How about that? So watch this. I'm not gonna have to press. I'm not gonna need to press the buttons anymore to do this. That's what's so cool about it. I can just go in here and make it red. Save that, build, and then go to the other window. Control C out, and then run it again. We don't need to wait 5 seconds. I wonder if we can just get away with 1 second, or I can try. Oh, now it's red. Look, the beautiful red color. Oh, I'm being rated. Retro MMO, you're rating me back. Hello. Hello, friends. You missed the dramatic discovery of what I was doing wrong for the last 3 hours. I have completed my quest for the day, which is my program can self-update. I don't have to press the bootloader button or the reset or any of that now. I worked today on this Flash programmer. So here's the function that I have that programs a sector of the flash memory. And this was my enemy all along. These two like archaic parameters. And I had set them both to 0 because the data sheet said they were optional. So I'm like, oh, optional means I don't have to worry about it. I can just do 0, right? And then I think it caught my eye at some point that they said typical sequence and they had non-zero values there. I'm like, maybe I should try what they have here. And lo and behold, that fixed everything. So yeah, so the whole thing for today on the journey to build my own keyboard is I want the controller for my keyboard to be able to update its own firmware and also update the firmware of its partner, right? Because you have a controller on the left hand and the controller on the right hand, like on my Corn keyboard here. There's a controller on the right and there's a controller on the left, and they're connected with this TRS cable that's dangling. So not only do I want to be able to program my controller through the USB, I want one controller to be able to like reprogram the other. So it has to be able to self-reprogram, and that's what this is all about. This is the core of it, programming one sector at a time. We're using routines that are in the ROM. We're looking them up, and then we're calling them in the correct order, and we're doing it one sector at a time. The sector size is 4 kilobytes, and we have to do it in 2 steps, and I can clean this up now because I don't need it. This is the final stage. We have to make sure we're running in a special linker section, so to make sure that our code is in RAM and not in Flash, because you can't reprogram Flash from Flash. And we set up a watchdog to force a reboot, because that's the only way with this microprocessor, or this microcontroller, to actually have it reboot itself, is to have the watchdog reboot it when it expires. We know where we staged the program elsewhere in Flash and how big it is, and so we just go through one sector at a time, basically reading it from Flash into RAM and then programming it back to the final destination in Flash. And we wait till I wait until I stage it all into a staging area first, because I don't have enough RAM to program. It's up to like a megabyte of Flash, so I only have 256K RAM. So we write it all into the second half of Flash and then copy the second half to the first half and then reboot, and we're done. What happens if you write 0 instead of D8? It's not going to work, Raimi. I'm not even going to touch it now because it works. So I hope you had a great stream, Retro MMO. I'm having a great stream now that I figured out what the heck was going on. It kind of sucked before. I can reduce... Actually, let me try... This is what I think is a good amount of time to wait. It's the size of the program divided into the number of sectors multiplied by 100 milliseconds. So it should be no longer than like a second or so total to reprogram everything. Let me try... Let me delete... I'm going to be very optimistic and delete the other code. Alright. And then I don't need this anymore. There's probably a bunch of warnings of things I don't need anymore, right? This, or commented out sections I can delete. Alright, anybody has any questions, let me know in the chat. If you were here yesterday, the code I had that receives the program over the serial port, I cleaned it up a bit so it's a little bit easier to read. It waits to receive the word program with a carriage return line feed on the serial port, and then if it sees that, it goes into programming mode, receiving the program size. When it receives the program size, it goes into receiving the program sector by sector, and that's basically filling up a receiving program array until it fills up, and then it programs it into a staging area. And then once it detects that it has all the sectors there, it goes and commits it, which copies it in, overwrites itself with the new program, and then reboots. So this is some crazy code, and like functions that don't return because we're purposefully rebooting. I should probably comment this. Go into an infinite loop on purpose in order to allow the watchdog timer to count down to 0 and trigger a reboot. Okay, so this is set up the watchdog to reboot us at the end. Note, we have to set it up now because ironically, the code that manipulates the watchdog is in Flash, is in the old Flash program, which we are about to replace. I was about to say blow away, right? But yeah, so this is copy each sector of the new program one at a time into RAM. I should say for each sector of the new program, copy it into RAM and then program it into its final... Wish I could type faster. Destination in Flash. You start a watchdog for like one after the right. We can't, I would like to wait until we know we need to reboot and then set the watchdog to 1, but then we'd be calling into the old program, which we just erased. I mean, the code for the watchdog should be there somewhere, but it's apt to move around as we change our program, right? Okay, so this is copy sector into RAM. This is program the sector in its final destination. Advance to the next sector. This is, I'm showing my overconfidence by commenting the code as if I'm finalizing it, even though I haven't tested it with the watchdog arrangement. Anyway, yeah. Okay, I can get rid of this, right? And then we can get rid of this comment because we actually are doing it. If we reach the end, move the program into place and reboot. Got it. Okay. Build. Actually, let's change the LED color while we're at it. What color do we want now? Let's go to white. I haven't seen white. Where's my code to do this? Here it is. White is 255, 255, 255. Build, and from now on, I can use my own bootloader. That's right. Let's do it. This one will have a 5-second delay because it's the old programmer still. But now we're on white. Look at that. Should I do magenta next? So that's white because it's all 3 LEDs. This NeoPixel, this smart LED, it's actually 3 LEDs very close together. So when you turn on all 3 of them, it looks whitish. Although if like you look at it at an angle, sometimes you can see the different colors on it. Okay, so now when it reprograms, it should be a lot faster. So someone said magenta. What's magenta? Is that back to green and blue? No, that would be cyan, right? 2550. That's what I've been using for days, though. Aren't we tired of that? All right. Do it. I think we didn't wait long enough. See, it's dead. Yeah, we didn't wait long enough. Let's wait a little bit longer. Okay. Yeah, it killed it in the middle of programming or something, right? So sector size is 4096, right? Oh, I wonder if this is overflowing or something, right? What if I put a parentheses around that? That's probably not it. Actually, no, it probably did overflow. So that would be safer. I should probably add 1. Just in case our program is under a sector. So it at least waits 100 microseconds. What's it telling me? Too many parentheses? Sure. No. It's wrong about that. I have too many parentheses somewhere. Or not enough. There. That's it. Hard to read all those parentheses. Fortunately, since I hosed it, I have to use the built-in Flash programmer. So here we go. One last time. Okay, it's Magenta. Let's pick something else. I fixed it, right, Rami? Okay, what color should I pick? I haven't tried cyan yet. That's 0, 255, 255. Yeah, there we go. Rami just typed it. So build, and we'll have my loader loaded. There we go. It works. So I think I overflowed the watchdog timer before. Oh, I can get rid of these programming sector calls now, right? We don't need those anymore. And that the dump stuff that we're doing for debugging, I don't need that anymore. I'm in the wrong program. Or I'm in the wrong window. Yeah, we don't need this right here. Which means I don't need to import it up here. Okay, and then the other thing was the programming sector. This one. We don't need to see that. What other infos is it doing? I mean, that's all I expect to be able to see before it reboots is what the size was. Maybe some of these lines if we cared to see them. I mean, I could leave this in. We don't end up seeing all of them because the ring buffer for the serial port doesn't get a chance to drain before we actually reboot the thing, or we go into the final commit. I'll leave it. All right. So let's try it one last time. Anybody have a color they want me to try? Are you using Vim for VS Code, or are you using cursor and is invisible? I think my cursor is just kind of invisible when it gets in. So there it is. When it's up here, it kind of goes invisible for some reason. That's happened before, and I'm not sure why. It's some artifact of Visual Studio or something, or could be OBS. Black, random for all three. Well, purple's magenta is what we've been doing before. How about orange? How do you get orange? That's like a lot of red and then like half green and blue. Actually, what? Anybody know it? Yeah, that's what we've been doing. 0xx to make magenta, so or purple. I want an orange. Anybody know what orange is? I'll look it up unless someone tells me what it is. That's what I was thinking. Use your username 29A. Orange color code. Here we go. Oh. So it's like a little bit less. Why don't we just use these numbers? There we go. I like a good orange. All right. Build. Doing this because it's the easiest, most observable side effect I can get. I don't know. It looks more yellow to me. See that? I mean, I guess it's orange on the camera. To me, it looks kind of yellow. You know, it's hard to get like faithfully reproduced colors. Get the green to be lower. So 70. Sure, I can try that. Here we go. Yeah, I could say that it looks more orange. What do you guys think? See, the camera's going to betray it. It's going to look more red. But next to that green, or next to that red wire, maybe it looks more orange than red. I don't know. Pure red on camera? Yeah. It's not as red as that red wire next to it. Okay, I'm happy. It's insane. It's insanely early in the morning for me now. So I need to wrap this up. Why did I have that in there? I don't know. I must have been debugging or something. Get rid of that. Okay, I'm even in the wrong program. It's this program I care about. Okay, what did I do in this commit? We got rid of the flash experiment. We're bringing in... Why am I bringing in flash self? Oh, because I'm referencing flash directly. All right, we're brought in the watchdog. Staging offsets in there. Okay, we're actually doing the program to the stage. And we're actually committing it. Got rid of the flash experiment. And we changed the color to a nice orange. And in the flash module, got rid of the, made the flash base public. I guess I'll leave that. Sector size also public. Removed the flash experiment. Instead, we have commit reprogram and program sector. And then there's the infamous change there to that, which you can't see because it's off the screen. Chat is, or my second camera is in the way, but trust me, that's the line that killed me for a bunch of hours. Okay, so git commit. Oh, I didn't add them. There we go. So this is get flash reprogramming to work. Okay, so write first to a staging area. 1 megabyte in. Once program, so I don't have any checks or anything. If the program gets to be more than a megabyte in size, we're going to have issues. Once program is written, copy it into place. And then the important one, fix a bug in flash sector programming. Where block, what's it? They call it block size and block command needed some magic values to work with the first flash sector. We don't know why. It worked for the staging area just fine. It just doesn't work for the first sector. Don't know. Remove flash experiment. All right. Push that sucker. Good morning, Everex. What happens if I try to write more than 1 megabyte? Then I will not be able, well, it'll run past the end of flash because I only have 2 megabytes total, and if my staging area starts midway through, then really my limit is 1 megabyte. If I try to go past that, I'll be trying to erase and program flash sectors that don't exist, right? If that part of the program isn't really that important, it might still work. And yeah, it could handle an overlap. It'll just, by the time it gets down to the 1 megabyte, it'll start overriding part of the staging area with the real program. But yeah, I think the big thing is that anything larger than half my flash size, I have problems where I can't run the current program and I can't store the current program and the new program simultaneously. I just won't have enough space. Gotta jump. Yeah, I'm taking off soon too, Rami. Or should I say, the artist, who is now called Rami. See that nifty artist badge that Rami has? Because he made some of the emotes for Adam's stream in this one. Pure red. Yeah, all right. Why is there a staging area when not write directly to Flash? Okay, that's a great question. So, you mean as I'm receiving it from the serial port, right? Let me go back to that. So, the way this is working is I'm receiving the program from the host byte by byte over the USB serial port, right? And that's happening over here in where we process the serial input, and we push the state machine, and we're in the state where we're receiving the program byte for byte, right? And we're programming the sector when we get enough, and then we keep receiving more. Problem is, if I instead of flashing to the staging area, if I flashed over my own program, then like, where is this code actually sitting? It's probably sitting in the same sectors that we're overwriting with the new program. So we will basically trash the program that we're currently executing. You won't break the device. It'll just, the CPU will start fetching instructions from the old, that were supposed to be from the old program, but are now in the new program, and they could be anything at that point. Won't the bootloader do that? This executes directly from Flash. It's called execute in place. So it's not like the bootloader loaded it from Flash into RAM. We're executing directly from Flash. So I can't overwrite Flash while running from Flash. I can only do it when running from RAM. So my Flash programming routines, I put into a special linker section to make sure they get linked and loaded into RAM by the bootloader. But I can't call anything else. I can only call, when I'm programming Flash, I can only call things that are also in RAM. And that's why I had to go through like really weird hoops to, like, I can't call just memcopy because memcopy is in Flash. So I had to do this manual copy, and I had to make sure really carefully that the assembly code for this actually was an unrolled loop and wasn't a call to memcopy. Actually, that's going to be a problem going forward. We saw the compilers flip to using memcopy for this, which would be disastrous. I have to somehow trick this, or maybe hand code this in assembly so that it never calls anything in Flash. You can ask a basic question. Sure, I'm pretty much done with the work today. Yeah, we can't brick the device because there's actually another ROM that we can boot to if I hold down the bootloader button over here. If I hold down this button and I boot, it goes into a special ROM that lets me reprogram the device. It looks like a mass storage device, and you copy the program file to that drive, and then it programs. So we can always recover. In order to trash this, I'd have to melt some fuses or circuitry inside with overcurrent, or burn it up, or something of that nature. What does loading a program to the CPU mean? Does it read certain bytes from storage into CPU? I kind of use the term to mean several different things depending on context. So all the work today, all the programming that I've been doing is to have the program running in here be able to update itself. The program code is stored in a flash chip, and it's a special kind of memory where it doesn't need power to remember the memory. RAM, like random access memory, usually the information is lost when you lose power, but on a flash memory, it persists. So the program is stored in that flash memory, and we actually execute that code directly from flash memory. So when the CPU is running and it's fetching instructions to execute, it's going out through a serial port to the little chip next to it. So there's two, if you look at this, there's two chips. There's a bigger one right there. That's the CPU. And then the little one off to the side is the flash. So the program is stored in that little one, and it's being sent over as needed while we're running to the CPU. So the challenge was to replace the program in the storage of the program while we're running that program from storage directly, which is hard to do. Can you overwrite the bootloader accidentally? The ROM bootloader is actually ROM. According to the datasheet, it's not programmable. So it was burned in the factory and it can't be changed, which is a good thing. I can't accidentally trash it. The worst that I can do is wipe out or trash the flash chip, and so when it boots up, it's like, I don't know what you want me to do. I think I'll crash now. It just will appear dead, and then I hold down the bootloader button and reset it, and then it boots into that special ROM bootloader, and I can recover from there. So you asked about the word loading a program. So I think of loading in this case as it could either mean that we're burning a new copy of the program into the flash, or we're actually running and we're loading each instruction at a time that we need to execute. So burning into the flash is a bulk operation. We like copy over 64 kilobytes and we're done. Loading, as in loading one instruction at a time, that happens naturally while the CPU is running, and that's like 2 bytes at a time. What's the bootloader doing byte by byte? My bootloader has to receive the information over this USB, and I'm using the serial port, the communications device class of USB, so it looks like a serial port, so it's literally like 1 byte at a time. Actually, it's 1 bit at a time with special start and stop bits in front and at the end. So I have to send the program 1 byte at a time, and the code that I have back in here is collecting it. It's kind of hard to see, but we're collecting it into this vector here. So we know the size of our program, and we know how far into it we are, and we're holding on to a vector of bytes. So we collect up to 4,000 of them, and then write it in one chunk to the flash. It's called a sector because it's really convenient the way the flash is designed to erase things in units of whole sectors, or 4K blocks at a time. Not burning in the cache, but executing the program. Oh yeah, when we're executing in place, it's actually loading on demand from the flash. But yeah, if you are in a loop and it starts to execute instructions that it already did before, like recently, it might load from a cache instead. So, but that's more of an optimization. We don't have to actually run with the cache on. In fact, it talks about it. It says that if you don't care about running from cache, you can actually disable it and use it as extra RAM. Where do they say that? Probably when they talk about RAM. Yeah, other on-chip memory, right? Besides the 264K, if you disable the execute in place flash caching, you have an extra 16 kilobytes. And if you're not using USB, whoa, my speaker decided to start chirping. If you're not using USB, the USB has its own 4K. You can use that too. Yeah, it's the RP 2040. Raspberry Pi. Yeah, the data sheet is really helpful if you're unfamiliar with the chip, and some of these data sheets are really easy to read. Actually, even if you're not familiar with embedded programming, you can kind of start picking things up, because it explains like how the flash interacts with the CPU, how it loads it 1 byte at a time over a serial port. This one actually has a 4-wire lane, so it's actually loading it a half byte at a time, is my understanding. Yeah, here's the block diagram of like how it works. So there's a cache in the middle. Where's the ARM sitting? Up here. I think that's, I don't know why they call it the main HBL slave or whatever, but this is the serial system serial interface or something like that, and down here is the flash interface, and it might bypass it and go through a cache. Anyway, some of the stuff is easy to read, some of it is hard. What can I say? I didn't write it. Half byte is a nibble, that's right. Yes. Each one of these is a nibble. There are 6 nibbles there. Okay, it's like 3 in the morning for me. I gotta go. I'm sorry. I should look to see what am I going to do next time. That way, if it's boring, you don't have to come back. But if it sounds fun, maybe you can come back. So I'll be streaming on Friday. What am I doing? Okay, we wrote to Flash. It's done. I could either jump into the CAD tool for the circuit board, or I could get into the controller to controller link. I could actually wire up a second one of these guys and have one program the other. That might be kind of fun. Yeah, I know you don't care about the boring part. Wait, we don't care. The boring part is usually more interesting. So if I did something really boring, you'd still watch. I'm actually running out of easy things to do. I think this is hard for me because I've never done circuit board design. I need to look up what CAD tools people use. Maybe I'll ask Adam or look at his notes. So Friday, it's either going to be I jump into the CAD tool if I have the courage, or I do the link between controllers. And I'll probably do that by having a second breadboard here and having it jump from one controller to the other. And my goal would be to have one program the other. I'm leaning towards that, actually, because it sounds more fun to me. But I know I'm putting off the CAD stuff. I need to get to that. Because once I get this CAD stuff done, we're basically designing the circuit board for the keyboard, and then I send it off to a company to have them construct the boards, and I get them shipped to me, and then it's just a matter of soldering on LEDs, diodes, the controllers, the TRRS connectors, and I don't even know if I can show that on stream because I literally can't put a soldering iron here without causing a fire hazard, but it's going to be a lot of work to actually physically construct the thing, but there's not much software left. Oh, well, I've done the matrix scanning, but I haven't done it for a much bigger. We've only done a 2x1. I gotta get it working for a much larger matrix, right? And then, okay, yeah, I should put in here. We're also going to need to deal with like combos. What is it? What is it called when you hold down a key and it becomes something else? It's like a hold. Tap versus hold. Modifiers. So like if you want to say a shift key or control key. Oh, board stuff. Yeah, I wanted to replace this because I do want to have LEDs, I think, and that the board stuff would be LED chaining or addressing. I'm thinking about using just the same NeoPixel that we have on this board and basically daisy chaining them all, and that would come into the PWB design, but I think that's just simplest because then I only need one GPIO for the whole daisy chain of LEDs and then just basically update them all at once. Is there a video on YouTube that explains detail of keyboard interface? There there are videos out there. People show how they're constructed, how they're programmed, but I don't know of one offhand. Do you know the fundamentals of doing PCB design? Okay, I can tell you what I know about PCBs. It's made out of fiberglass with copper wire in it. It's multiple layers, so you can have like two wires cross one above the other and not conduct between them. And you have these things called vias, which are like a wire that's going vertically. So you can go from one layer to another if you go pass through a via. And in addition to copper wires, you're going to place pads where you're going to hook up the pins of the controller, the sockets for the keys, and other things. And I know that we have to get the dimensions pretty accurately. PWB is printed wire board, and PCB is printed circuit board. And Mrs. Reimer was explaining to me that a PCB is what you get when you take a PWB and you populate it with soldered components. But I don't know. Is Mrs. Reimer right or not? I haven't looked it up to make sure. But the PWB, for sure, I can design in a CAD tool and have it sent off and shipped back to me, and then I do the soldering of the components on top. I never verified our RAM usage completely, and I never, I should put onto here, place the heap in a proper way. I have it hacked right now. I hacked the heap into place with hard-coded memory addresses, and I really needed to basically work with the linker to pick a region that's not overlapping anything else. Etching. Isn't the etching process where you start with a sheet of copper and then you just eat away with acid where you don't want the traces and stuff? The note-keeping software is just one note. Where's my typo? Oh, itching? I mean, you're using acid, so it is going to itch, right? My notes link will get you to an online version of it. I'm just using OneNote. Yeah, so I think what I'm going to do when I come back on Friday is I'm going to get a second controller, one of the production controllers, and try to get one to program the other. Place the heap in... Oh. Properly. Place the heat in... What did I mean to type in there? Memory. Properly. Thank you for that. Any proper way? That works too. I'm tired. In a proper way. Oh, I see. And it changed it to properly? Or I did. I'm half falling asleep. I gotta go. But I'll be back on Friday working on, I think, the link between controllers. And we'll see how it goes. Let me go rate somebody. Thank you, everybody, for sticking with me. I don't think anybody that I follow is streaming right now. There's Grumpy Game Dev working on a game in VB.net. Or there's Chulade, who's doing some art in Unreal Engine. And there's Auroral Games. And those are all the people I'm following that are on right now. Oh, you're welcome. It's been 7 hours. I never expected to stream this late. Yeah, I'm sorry. I'm not gonna really be up to rating someone I don't know. Okay, well, Auroral Games is always kind of interesting doing game dev and art and stuff like that. So let me raid them. Got to rate someone, right? You can't just leave you guys in the void. Ah, I'm getting an ad. I'll let this raid start while the ad is going. He's a programmer for Java and Python. Okay, what I'll do is I'll jot that name down and I'll watch their stream and I'll follow them if I like them, and then they'll be on my candidate list for rating. How about that? Jotting it down. Thank you for the suggestion. You're banned there. What'd you do? Were you naughty? I don't know. You don't have to follow the raid, but I have to leave you with someone. So anyway, I'm going to go to bed. Thanks for watching. See you on Friday. Bye.